Okay, we're going to do 1.2 part 1 review here. The first problem, reduce 216 4/88. Try this on your own and then come back in and see what I get here. Now the idea here is to keep dividing the numerator and denominator by the same numbers until you get the smallest possible fraction. Well, they're both even numbers, so you know they divide by 2, so we can just cut the fraction in half, numerator and denominator. We get 108 2/44. Then we can do that again and write 54 1/22. We can do that one more time, 27 61. And that cannot be reduced. The only thing that divides into 27 is 3 and 9, and neither 3 nor 9 divide into 61. Next problem, write 5/16 as a decimal without using a calculator. Just a simple long division problem. So we set this up, 5 divide by 16, put in some placeholders. After 5, a decimal point, which will go straight up. Then you start dividing. 16 goes into 50 3 times, so the 3 goes right up there above the 0. Then we multiply 3 times 16, 48, subtract to get 2, and then we carry down one of those zeros, 20. Now we start the process again. Divide 16 into 20. It goes in one time. And then write the result, subtract, carry down, see if you can finish this result, or finish this problem and get the result. So 16 goes into 20 once. 1 times 16 is 16. We subtract, get 4, and then carry down the next 0, 40. 16 goes into 40 twice. 2 times 16 is 32. Subtract, we get 8. Then we need another 0, so I have to add another 0 here to carry it down. Finally, 16 goes into 85 times. We multiply. 16 times 5 is 80. Subtract, and we're done. So the steps are always divide, multiply, subtract, and carry down. And I know you have calculators to do this, but it's nice to be able to do simple divisions like this in a pinch. Also, if you go on in algebra, this process of dividing, multiplying, subtracting, carry down is used in dividing polynomials. So this is a helpful concept if you're continuing with algebra. Okay, in the next problem, we're going to write 5/11 as a repeating decimal without using a calculator. Again, we're going to divide 5 by 11. Set it up like we did in the previous problem. 5, decimal point, a bunch of zeros. Start dividing 11 into 50, which goes 4 times. Subtract, carry down, and continue that process till you see a pattern. So try to finish this problem. So here we get 4 times 11, 44. Subtract 6, carry down a 0. 11 into 60 divides 5 times. Multiply 5 times 11 is 55. Subtract, get a 5, carry down a 0, 50. 11 goes in there 4 times. Subtract, carry down. 11 goes into 65 times, and we see the pattern. So 0.4545, we write that as 0.45 with the line over, because we're going to keep getting the 4, 5, and the 4 and the 5. So that's our answer. Next problem, write 0.084 as a reduced fraction. Okay, the way we do this is first we write it as a fraction over the power of 10, then reduce that fraction down. So, as done in lecture and in the notes, we count the number of places. There's 3 places. That means 3 zeros in the power of 10. So we place 84 over 1 with 3 zeros. So it's 84 thousandths. And then reduce from there. Well, as we did in the very first problem, we can just cut the numerator and denominator in half and repeatedly as much as we can. So we get 42 500ths. Do that one more time. 21 2/50ths. The only thing that divides into 21 are 3 and 7, and neither of those divide into 250. A divisibility test for 3 is if you add the digits up, 1 plus 2 is 3. If that sum is divisible by 3, the number is divisible by 3. So 21 is divisible by 3. Let's say I have the number 3, 4, 2. That number is divisible by 3 because the digits add up to 3 plus 4, 7 plus 2 is 9. And 9 is divisible by 3. So 342 is divisible by 3. It's a nice divisibility rule to remember. Along with even numbers are divisible by 2, and numbers ending in 0 are divisible by 10 and 5. Okay, next problem, write 62.5% as a decimal and a fraction. Now the first thing you want to do is change that mixed number there into 62.5 because 1/2 is 0.5. So that's 62.5%. Actually, mixed number percents are they're never used in real life. But in textbooks they're shown, so I just had a problem or two demonstrating what you do with them. But you always want to turn those goofy mixed number percents into decimal percents. Now that we've got that fixed, now we can turn it into a decimal by using the rule of 2 places. And that says move the decimal point 2 places, the percent will always be the bigger number. So if we move the decimal point to the right, we get 6250, 6,250. Well, the percent has to be bigger. So that means the decimal point has to be moved to the left. So it's 0.625. Now again, we can write that as a fraction, placing 625 over 1 with how many zeros? Well, 1, 2, 3 places, 3 zeros. And since I don't ask for it to be reduced, we could leave it as that answer. If we wanted it reduced, we would then have to reduce it down more by dividing by common factors. In this case, 5 would have to divide into both the top and the bottom. And then you might be able to divide it by 5 again. Okay, next problem, write 4.21 as a percent. A lot of people get confused about this and think, well, I write it as 4.21%. No, this is the decimal, 4.21. We have to move that decimal point 2 places. Now, if we move it to the left, we get a smaller number. That means we have to move it 1, 2 to the right. So it's 421%. Just like 1.0 is 100%, 4 point something is over 4 times that much. 421%. Okay, next problem. Write 0.2% as a reduced fraction. And people, for some reason, always get this problem wrong, even to the end of the course. So pause the tape right now and try this on your own. See if you can get the correct reduced fraction. And your first step here should be to rewrite this as a decimal. So we move the decimal point. If we move it to the right, we get a bigger number. Percent always has to be the bigger number. So we have to move it to the left. That means we're going to have to add a 0 placeholder. So we're going to get 0.002. So if you haven't done that correctly, rewrite that. Now turn that into a reduced fraction. So we place the 2 over 1 with 1, 2, 3 places, 3 zeros. Then we can just cut the numerator and denominator in half and write 1 over 500. Okay, final question. This is like number 12 of the homework. How would you represent this pi? And it's a multiple choice question. So here I have, how would you represent 10/3 of a pi? Now if we go back to the basics of fractions, the numerator tells you how many pieces, the denominator tells you the piece size, or pieces per whole unit. So if we had pies here, we would be cutting these pies in thirds. 3 pieces per pie. Well, 1 pie gives us 3 pieces. Well, we need 10 pieces. So we need another pie to get us up to 6 pieces. And 1 more pie gets us up to 9 pieces. And then we need that 1 piece out of the 3rd pie. So we cut up pies into 3 equal pieces and we choose 10 of those pieces. And there I have the answer in red. Cut up pies each into 3 equal pieces and choose 10 of the pieces. And we see that it makes the mixed number 1, 2, 3 plus 1/3. And that's how we get our mixed number. 3 whole units plus 1/3 of the last unit. So that's it. If you have questions, you can post them on discussions or ask them in a review session on a Monday as well.